We're taking a problem from section 2.3, problem 67 on page 55. We have a car A and car B. Car A and car B. We know that car A is traveling at 75 kilometers per hour, and car B is traveling at 85 kilometers per hour. Of course, I could write both of these as 75 kilometers in 1 hour, or as 85 kilometers in 1 hour. All right. We would call this a speed, right? This is the speed of each of these vehicles. This is the speed. This is also speed. All right. Now, they both leave from school from the same position at the same time, at time equals 0. So at time equals 0, they're here at school, wherever that is. That's where they're leaving. What we're tasked with doing is drawing a position time graph showing the motion of the car over the 3 hours. So when they go from school and they're going from school to whatever their location is, we want to know what we want to represent that motion in a position and time graph. I'm going to leave this here. We'll be able to fill that out actually as we fill out a table for this. Our independent variable, as always in this situation, is time, which will be measured in seconds. That'll be on our first column. In our second column will be the distance for car A. We'll call that d sub A. Okay. And then in our third column, we have distance for car B, which we'll call d sub B. At time equals 0 seconds, the distance, and we'll be measuring this in kilometers, parentheses, kilometers, parentheses, kilometers. At time 0, both are at the school, so they haven't traveled any distance. And we have time here measured as seconds. That shouldn't be there. I should put it hours, right? Because we're going to look at over a period of 3 hours. Over a period of 3 hours, what is the position of each of these cars? At 1 hour, how far would car A have traveled? Well, car A travels at 75 kilometers for every 1 hour. We traveled for 1 hour, so we get 75 times 1 divided by 1, which is just 75 kilometers. 75. We could do the same math for car B, and we'd say 85 kilometers. What about for the second hour? The second hour, we can do the same math. Now we have 75 kilometers for every 1 hour, but now we've traveled for 2 hours. So we get 75 times 2 divided by 1, which is 150 kilometers. 150. Similar math here, except this would now be 85, and we would have 85 times 2 hours, which is 170 kilometers. Finally, we can add our third data point here, and we see that this would end up being 225 if we take 75 kilometers per hour times 3 hours, and then here we'd end up with another 85 on top of this. So 85 kilometers per hour times 3 is 240 plus 15, so 255 should be 255 kilometers, right? I think that's right. Let me do that math real quick. 85 times 3, 80 times 3 is 240. 240 plus 3 times 5 is 15. So this should be 255. All right. And that is correct. All right. So now that we have a data table that we created, then we can actually create a chart, or a graph, rather, that's appropriate to this. So we'll make this here. My dependent, or rather my independent variable, is that of time. I'll put time on my horizontal axis, time measured in hours. On my independent variable, or rather my dependent variable, so my vertical axis, I'm writing distance as measured in kilometers. All right, one of the last things I need to do is put tick marks on here. The appropriate amount of tick marks I'd have here would probably be 1 hour, 2 hours, 3 hours, and then 4 hours. We're only needing to do over 3 hours, but we'll show it over 4. The distance. Well, if we look at our data table, that gives us a good idea of the distance. We're going from 0 all the way as much as 255. I have 1, 2, 3, 4, 5, 6, 7, 8 tick marks. 255 divided by 8 is something. 255 divided by 8 is a little bit more than 30. So I'm going to say 40 for each of these. 40, 80, 120, 160, 200, 240, 280, and then finally 320. All right. They both start at the point 0, 0 right here. Okay. After 1 hour, first car has traveled 75, pretty close to the 80. Second car has traveled at 85, just over the 80. Second hour, we have 150 for car A. 150 is just below the 160. For the car B, we have 170 at hour 2, so just above here, right? And then for the third hour, we have 225 for car A, which is almost halfway, a little bit more than halfway in between the 200 and 240. And then 255 for car B, which is just over this guy here. All right. We can draw a straight line. We can draw a straight line here through our data points. Straight line here through these data points. Right. There is a position versus time graph for our data. When I look at this, I can't see as clearly the fact that this line here, which is for B, and this is for A, that these have differing slopes. They really do. They both intersect the point here. Car B has a steeper slope because he has a greater speed. The slope of this line for a position versus time graph is the speed, right? Because if we were to calculate change in y over change in x, well, the change in y is the change in distance. The change in x, or the horizontal axis, is time. So our slope m equals change in distance over change in time. That is speed. So the slope of these lines corresponds to our speed, right? What I'd do to maybe demonstrate this a little better, that we have a steeper slope in B than A, is having smaller units. So maybe I should have chosen 30 here for each of these designations. All right, that answers the first part of A. The question is, how far are the two cars from school whenever the stopwatch reads 2 hours? We have that demonstrated here in the data table. At 2 hours, car A is 150 kilometers. Car B is 170 kilometers from the school. We calculated those distances, and then we show them on the graph. Here is where they are at 2 hours each. On the graphically, there's where they are on the data table. Part B is both cars passed a gas station at 120 kilometers from school. 120 kilometers from school is right here. Here's 120 kilometers. When did each car pass the gas station? I could read over to each of these graphs if I had drawn it a little better. Not a greatly drawn graph. So I'd see wherever it intersects, wherever this 120 intersects these lines, and whatever time that corresponds to on the horizontal axis or on our time axis. See where it first intersects B is at a time that's less than time for A, where it intersects at A, intersects the line at A, or 120 intersects line A for car A. That makes sense because car B would take less time to travel that same distance of 120 kilometers. How could we mathematically demonstrate that? I'm going to demonstrate it over here in the region. That's how we graphically see it, but we want to find what precisely is the number there. The equation for each of these lines, D of A, is 75 kilometers per hour times time. For dB, we have 85 kilometers per hour as our slope, right? As our speed times time. There's no plus b here. Both of these are linear equations, right? There's no plus b in our y equals mx plus b. Why? Because both started from the start point of 0, which was the school. All right. If we wanted to find out once they had each traveled 120 kilometers, we just plug in 120 for the kilometers for distance A. And then we just solve for time here. To get time by himself, we need to divide by the 75 kilometers per hour on both sides because of our equal sign, to keep them equal. The 75 kilometers per hour cancels on our right side, so all we're left with is t equals 120 divided by 75 kilometers per hour. We would do the same math for d sub b, where we'd plug in our 120 kilometers for the distance of b equals 85 kilometers per hour times t. We see here that t equals, for distance of b, how long it takes for it to go, 120 kilometers, is the 120 divided by 85, which is 1.4 hours. The t up here, rather the t all the way up here, my bad. So t for A, this is t for B. The t for A is 120 divided by 75, which is 1.6 hours. Now when I put 120 divided by 85 into my calculator, I get a number something like 1.4118, right? But I can only have two significant figures here, 1, 2, because each of these only has two significant figures, right? So I would have a quotient here, right? Here's my quotient of kilometers divided by speed, or a distance divided by a speed, which is what gives me the time. That time is calculated based upon these two measurements. Each of these measurements only has two significant figures. So both of my answers for time of B, how long it takes car B to reach 120 kilometers, and the time it takes car A to reach 120 kilometers, are both only measurements with two significant figures. All right, thank you.